All right, so we're going to talk about classifying some angles today and working on all the things that make up angles. So angles, we've seen angles before. We know what they look like. We can see a diagram there. An angle is formed by two rays. So this is yet another vocabulary word along the way. A ray is it's half of a line, basically. You've got a starting point and then a line that continues in one direction. That's what a ray is. So ray BA and ray BC are what those rays are called. So then you have your starting point, which is normally like the corner of an angle when you're talking about rays. But ray BA and ray BC are what those are called. So when you talk about rays, it has a starting spot and the line continues in one direction. It does matter what order the letters are in when you're naming rays, because you always want to start with your end point on a ray out of that. So be careful of that as you're naming rays, that you always start with the end point in mind, okay? The common endpoint is called the vertex. The rays are called the sides of the angle, okay? So we have vertex is that corner, and then the sides of the angle. The name of the angle, to name an angle, you can use the three points that are on there. So a point on one side, the vertex, and a point on the other side. So we can use three letters. The middle letter has to be the corner, though, has to be the vertex. Okay, so we could name this particular angle ABC, or we could name it the other direction, CBA. It doesn't matter what order you go in that way, as long as the vertex is in the middle. So when you're naming angles, make sure you put your vertex in the middle. That's one thing that we've got to make sure we're doing. Or we can use a single letter if there's only one angle at that vertex. So with this example, there's only one angle in the picture. So we could just call this one angle B because it's the only one there. If there were other line, like if there were another ray here coming out of that had like point D on there, we couldn't just name it angle B because there's more than one angle at B out of there. So if there's more than one angle, you've got to use the three-letter style. If there's only one angle in your diagram, then one letter is enough. The corner letter is enough to do that. Okay. So for this one, you've got when referencing the measure of an angle, we use a lowercase m noted right there. The measure, you read that, the measure of angle ABC is 60 degrees. That's the way that we talk about the measure of angles. So this is kind of like when we talk about segments, we took the bar off the top of it when we talk about segment length, the size of that segment. With angles, when you talk about angle measurement or how big the angle is, you have to put that measure of angle, whatever, on there. Okay, so that's how you talk about that. That's going to be important when we get into proofs later on. So if we'll learn that notation now, it's going to help us out when we get into those proofs later on. And types of angles, this is real simple stuff that you probably know already. What kind of angle is this first one? Acute. Yeah, things that you know already. Acute angle. What does it mean to be acute? Yeah, less than 90 degrees. And then the second angle there, obtuse is the right word. And that means greater than 90 degrees. And then the third one is a right angle. And most of the time, if a diagram has a right angle in it, they're going to put that little box in the corner to tell you, hey, this is a 90-degree angle. You don't have to measure it or anything like that to find that with this. It's automatically given to be 90 out of that. And then the last one may be the one we may not know. I don't know. Well, it's a line. That's true. It looks just like a line. What we call that is a straight angle. And what does that equal? 180 degrees. Good job. All of those things going on there. So classifying or types of angles there, really easy to do based on those names. And we're not going to have to actually get out a protractor and measure angles today. We should be able to recognize it by looking at it, whether or not it's acute, obtuse, right, or straight. Out of that, we should be able to recognize that. We won't need the precision of a protractor today. So example one there. We got a diagram on the left. It's the only angle in that picture. So part A says name the vertex of that angle. Okay, good job. Name the sides of that angle. What are they though? Rays. Okay, so how do we write rays? Remember how we wrote lines and line segments yesterday? To write ray KL, you're going to put a ray above it. So it's an arrow basically above it. A line, it's got arrows on both ends. A ray is only going to have an arrow on one end. Remember, you've got to start with your vertex, or in this case, it's the vertex of the angle, but it's the beginning point of that ray. So ray KL goes that direction. The other one would be ray KJ. You want to name it that. KL and KJ. That's what those are. All right. So part C says give 3 ways to name that angle. Okay, so angle JKL, that's one way. Angle, and got to be careful. I'm bad about not making my little angle symbol squished enough, and my L's tend to look like angle symbols, so I'm going to try to be very careful there. So angle LKJ, one other way. Angle K. Why can we name this one angle K? It's the only one in the picture that has that vertex. That's the reason we can name it that. Okay. All right. Let's classify that angle. Obtuse. And by default, we're always going to look to the smaller side of the angle. Most people don't look at it this way, but I tend to look at, you guys know I don't think the same way as everybody else. Technically, there are 2 angles in this picture. There's this angle on the back side, and then this angle on the inside there. By default, in geometry, you always look to the smaller. So we're classifying this angle in here, not the one on the other side of there. But just in general, in high school geometry and in most geometry classes, you're going to look at the smaller angle as the one you're classifying, not the larger one out of that. Okay. Easy enough. Example 2. Another easy one. Name the vertex of that angle. Name the sides. What SR and what ST? Ray SR and ray ST. Just being specific, being intentional about some things there, as we're getting into this notation stuff. Okay, 3 ways to name that angle. Angle RST, angle TSR, and angle S. Classified. Right. All right, easy enough. Congruent angles. If the measure of angle A is equal to the measure of angle B, then the angles are congruent. So then we could say that angle A is congruent to angle B. Equal sign when we're talking about measurement, congruent sign when we're talking about objects. Okay? I put an equal sign on the measurement line. On the object line, the last one, that's talking about objects, so I use a congruent symbol. Okay, when I talk about measurements, I use an equal sign. When I talk about objects, I want to use a congruence symbol. Okay, so that's a notation thing. Doesn't seem like a big deal, but it really is, especially when we get into proofs later on. I keep saying that, and I'm tired of hearing myself say it all already. You'll be tired of it for sure once we get there. Probably you're like, I hate proofs. I like them; they're fun. Kind of like word problems; they're a lot of fun. All right, angle bisector. So we had bisectors when we talked about segments. What did the bisector do when we talked about segments? Cut it in half. So an angle bisector is going to do what? Cut the angle in half. Okay, so a ray that divides an angle into two congruent angles is a angle bisector. So it's a ray that cuts or divides an angle into two congruent angles. In the diagram on the right there, it says blank is an angle bisector. Okay, so what's the angle bisector in that picture? Ray BD. Good job, guys. Ray BD. Therefore, what two congruent angles do I get? ABD, and then angle, congruent symbol, angle DBC. Why do I have to use the three-letter way of naming those angles? Because there's two of them out of that same vertex, so be careful of that. And that's not the only way to name those angles. Remember, you can just change the order of the two end letters, and it's the same angle. Just as long as your vertex is in the middle, you're good. Okay, they're really easy. And the notation that they're showing here is these are actually two separate little arc marks. It's one arc mark for that angle and then another arc mark there. That's showing this angle ABD is congruent to angle DBC. So little arc marks. With the segments, we did a little slash through the segment to show that they were congruent to one another. In diagrams, if you see these little arc marks, that means those angles are congruent to one another. Out of that. So that may be something that comes up as we go along here. Like example, when we get into the example 3 there, you can see it already. Let's talk about perpendicular lines. A little bit of notation involved with this. Two lines that blank at a what? Intersect at a, what's special? Lines intersecting is not so special. But if they're perpendicular, what kind of angle do they intersect at? At a right angle. You can see in that diagram over there, they got a right angle mark there. So perpendicular lines intersect at right angles. So that makes them pretty special. The symbol for perpendicular is an upside down capital T is what it looks like. It's an upside down capital T. That's perpendicular. So when you see that, you read it as perpendicular, meaning that all those angles are 90 degrees. In the diagram on the right, we can say how are those lines named? L and M. So line L and M are perpendicular. So the way that you could write that would be L is perpendicular to M. I'll make that more of a script M. L is perpendicular to M is how that can be written. So that notation is going to become more and more important as we go along. It is pretty special when things are perpendicular. You think about if anybody has a family that builds things or you enjoy building things or you built a house recently, you want to make sure your walls are perpendicular to the floor. That makes them stronger, makes them things work out nice. You want to make sure the corners of the room are perpendicular to one another. So it's really special that things are perpendicular. It's important that they are. So that's going to become more and more important. A perpendicular bisector is a bisector of a segment. So it's a line, segment, or ray perpendicular to a segment at its, what's a bisector hit? The midpoint, that's right. So it starts bridging in between what we've already done now. So we got a perpendicular line or ray or segment that hits another segment right at the midpoint, and it creates a perpendicular bisector. In the diagram on the right, what is the perpendicular bisector to segment? I'll go use segment PQ. Line LM. And we use the notation for line, which is an arrow on each end. I'm going to swap to a skinnier pencil. All right. So perpendicular bisector, we see the notation. We got the perpendicular mark, the right angle there. We see the two little hash marks on the segments from P to the midpoint and Q. The midpoint and Q, those are the congruent segments out of that. All right, let's look at example 3. Kind of put some of this to action. We got this diagram over there on the left. A lot of stuff going on in that diagram. Quite a few angles in there. It says write another name for angle CBF. So FBC would be a great one. That works great. And again, just trace it out, know where it's at. And then go the other direction. That's the best way. Why can we not just name that angle B? Oh yeah, there's a whole lot of angles coming out of B right there. All right. Name the sides of angle EBD. So EBD. Say it again. Logan, say it again. BE and BD. What BE and what BD? No. Ray. There you go. See that in the diagram? But notice where it comes from in the notation of the name of the angle. The name of the angle is EBD. We got a ray BD and a ray BE. You can get it out of the notation out of that as well. One of the things that I kind of try to make sure that you notice is that the notation and the diagram should always match up that way. When you're talking about, I should be able to look at your notation and not look at a diagram and be able to tell what's going on. If you do your notation correctly, I don't have to have a diagram. Diagrams are easier, but notation and diagram should match up. Okay, classify angle ABC. Straight, good. Give an example of an obtuse angle in that picture. Angle ABF, good job. Can we get another one? EBC? EBD? There's several in there, right? How many do we need? One, because that's all it asks for, right? Okay, so know that that's not the only correct answer. There are others. Technically, is a straight angle obtuse? Yes. So we could do the straight angles as well. They're technically obtuse because what's the definition of obtuse? Greater than 90. Is a straight angle greater than 90? Yeah, it's twice as big as 90, so it's definitely bigger. Okay. E part. Excuse me. Name 2 congruent angles. EBA and CBF. Yeah. It's congruent to angle CBF. Those are the only two that have the congruence marks on them. That would be. And then F, name a perpendicular bisector. Ray BD. Why can I not call it line BD? Yeah, it doesn't have an arrow coming out the other side out of that. So be careful. Don't add anything to your picture. Really just use what's there. Okay. Example 4. Big picture things here. Now here's to introduce another kind of naming structure when you have a picture that has a lot of angles in it. A lot of times they will be nice, and it makes it a little easier when they put numbers inside of the angles, and then you can name based on that number. You can name this angle is angle 1. This is angle 2, 3, 4, and 5. You still have the same naming conventions with the letters that you can use, but when they put numbers in the picture originally that you get, then that helps you out a little bit. Makes it nice for you. So when we look at that one, it says name the vertex of angle 2. Point T. Good job. Name the sides of angle 4. Ray TW and Ray TZ. Good job. Write another name for angle 3. UTZ. Good job. Another name for angle 1. Yeah, YTX. Good job. Classify angle YTW. Right. YTU. Obtuse. Good job. XTU. Okay, when you get the quiz on this, whatever you think first, do the next one. WTX. Straight. Is it obtuse? Technically, yes, but which one is the more descriptive answer? Straight. Okay. Yes, it is obtuse, but that's not the fully correct answer. It should be straight there. All right. Name 2 perpendicular lines. Try again. Two perpendicular lines. Okay, line YZ. Arrows on the ends is perpendicular to line W. What'd you call it? WX, yeah. I just wanted to use the same letters you said. And I'm just writing the perpendicular statement for the lines. I think you can just list it with commas there, since it didn't say right 2 lines that are name an angle bisector. Ray TU is an angle bisector there. All right. Easy stuff, right? Nothing to this, okay? So basic introduction to some angles and classifying them. Let's get into the angle addition postulate and talk about that. So this is going to be very, very similar to the segment addition problems. We're just dealing with angles here. So the pictures can somewhat get a little bit more cluttered because you can have a bunch of angles in a picture, more so than you can with the segments. Segments, you basically got one segment, and that's about it. So angle addition can sometimes get a little tougher just because there's a lot of distractors in there. So first part there says angle, if D is in the interior of angle ABC, then angle ABD plus angle DBC is equal to angle ABC. Those two small, all that says, the angle addition postulate, all it says is that two smaller angles that have the same vertex add up to be the bigger angle that they create. That's all that means. Those two smaller angles add up to be that bigger angle. That's all that says. So really, really not too fancy there. All right. So let's look at those examples. Really easy stuff here. So in the diagram for 1 and 2, we're going to use this picture. It says if the measure of angle ABD and the measure of angle DBC are 48 degrees and 78 degrees, find the measure of angle ABC, so the bigger one. So what do we do with those? Add them up. So I'm not going to be too tough on you here. So 48 plus 78, 126 degrees. Make sure you put your degree symbol there, is equal to the measure of angle ABC. Not, that's no different than the segment addition stuff was. Number 2, angle DBC is 74 degrees. Measure of angle ABC is 119 degrees. Find the measure of angle ABD. So you're going to end up subtracting those. That's right. So 119 minus 74. How much? Much more. 45.
No, that's 35. Because once you get to 30, yeah. No.
No, it's 45.
That's right. Okay. I was
You were getting closer. You're working your way up to it. Example 3. If the measure of angle PQR is 141 degrees, find each measure. So they've got a list of things they want us to find here. We have a picture of things involved here. So how do we set up the equation in order to be able to solve this? Are they equal to each other?
No.
No, they're not equal to each other.
13x plus 4 plus 10x minus 1 equals 141.
Good job. All right, so angle addition postulate says if I add up the two smaller angles, they should add up to be the whole angle. And that's the measure that they gave me, was the whole angle, the big PQR. So 13x plus 4 plus 10x minus 1 is equal to 141. And we're going to solve that equation. Good old easy algebra 1 stuff there. So 23x plus 3 is 141. Subtract 3. 138. Let's see. 6. So x is equal to 6. And then we want to find the measure of angle PQS. So what do? Plug it into 13 times 6 plus 4. That'd be 78 plus 4 is 82 degrees. And then SQR, 10 times 6 minus 1, 59 degrees. Make sure you put your degree symbol on there. Be picky about that. Number 4. Angle DEF is 7x plus 4. The measure of angle DEG is 5x plus 1. And the measure of angle GEF is 23. Find each measure. Good job. Really easy setup. Work it out. 5x plus 24. And so that'd be 20 equals 2x. X is 10. And then go back and plug back into those things. So 10 times 5 plus 1 would be 51 degrees. And DEF would be 74 degrees. Right. Nothing really daunting here. It's just pretty easy stuff. Let's hit up number 5 there. The measure of angle JKM is 43 degrees, and the measure of angle MKL is 8x minus 20. The measure of angle JKL is 10x minus 11. So this one's a lot like 4, right? 43 plus 8x minus 20 is 10x minus 11. Solve that up. The 2x is equal to 34. So x is 17. And 8 times 17 minus 20 be 80, and 56 would be 136 minus 20 would be 116. And then 170 minus 11 would be 159. Does that make sense that MKL would be an obtuse angle? Does it look like an obtuse angle in the picture? Yeah. Does JKL look like an obtuse angle in the picture? Yes. One of the things that you'll read at the beginning of the math portion of the ACT is they'll say diagrams are not drawn to scale, and then they'll have problems like this on there, and they'll lie to you and tell you it's not drawn to scale. Guess what? They're always drawn to scale. I've never seen one that isn't. It really does work out that way. So when you look at a problem, especially when it comes to ACT and stuff, and in this class too, the diagram really does match what's happening in the description of the problem. So if it looks obtuse, it probably is. Okay. If it looks like an acute angle, it probably is. Okay. If it looks like a right angle, that doesn't necessarily mean it is, but it should be somewhere close to 90 degrees if it looks like a 90-degree angle. All right. So let's look at number 6 there. Angle DEF is a straight angle, and the measure of angle DEG is 23x minus 3. The measure of angle GEF is 12x plus 8. How do we set up this problem?
23x minus 3 plus 12x plus 8 equals 180.
Good job. 23x minus 3 plus 12x plus 8 equals 180 because we're dealing with a straight angle here. And then solve it. 35x plus 5 180. 35x equals 175. B5 maybe. And then go back and reverse plug in. So 5 for DEG is going to be 23x. 23 times 5 would be 115. Minus 3 is 112 degrees. DEG, 112 degrees. That seems like it makes sense. And then GEF, plugging that in, 5 times 12 is 60 plus 8 is 68 degrees. And we already knew that DEF was 180 from knowing it's a straight angle. Easy stuff, right? Number 7, measure of angle TEW is 5x plus 3, or TUW is 5x plus 3, and the measure of angle WUV is 10x minus 5, and the measure of angle TUV is 17x minus 16. Somebody give me a setup on that one. Good job. So 2 smaller angles add up to be the larger one. And then we just got an equation that has variables on both sides that we got to work with here. So 15x minus 2, 17x minus 16. 14 is equal to 2x, and 7 is equal to x. And then we got to plug that into all of these and work it out. So 5 times 7. 35 plus 3 is 38. And then 70 minus 5, 65. And then 70 plus 49 is 119. Minus 16 is 103. What's the check to make sure that that's right? Add the two smaller angles together, make sure they equal 103. They don't, something went horribly wrong out of that. So be careful of that. Really, really easy to make simple math mistakes when the math is so simple for you. 8's a little tougher. This is the ones where I usually see folks starting to sweat a little bit on this stuff just because they kind of struggle at setting up word problems. But a lot of you that had Algebra 2 last semester should be good to go on this. I hope. Not, I may go. Measure of angle ECD is 6 less than 5 times the measure of angle BCE. And the measure of angle BCD is 162. Find each measure. Do we know the measure of angle BCE? No. So I'm going to call it X. So this is X. How much is this angle? The ECD. Okay, so it'd be 5x minus 6 is what I heard there. Good job. Now, what do we do with that? What equals 167? No. Yeah, x plus 5x minus 6 equals 162. Because you got to add the two small angles to get the big angle. So that's going to be 6x minus 6, 162. 6x equals 168. 28. So x is 28, but that's also the measure of angle what? BCE. That's what we called x. So there's the 28 degrees goes there. And then how can we find the ECD? Yeah. So you could do that or subtract that from 162, which I think is the easier thing to do, right? So if you subtract 8 from that, it'd be 154 minus 21 would be 134. Either way, it should get you 134, whether you plug it into 5x minus 6 or subtract it from the 162. Both should match up. All right, just a couple more. We'll be into the practice for today. All right, use a diagram on the left to answer the questions for 9 and 10. This is the much more complicated diagrams. That's what I was talking about earlier. So a lot of angles in that picture. So you've got to be careful that you're talking about the right ones. So for number 9, if the measure of angle ABF is 6x plus 26 degrees, and the measure of angle EBF is 2x minus 9, and the measure of angle ABE is 11x minus 31, find the measure of angle ABF. Whoa, a lot of stuff. So we know angle ABF is that one. All right, and we're going to go around this direction because that's where all the other angles are. And then we know that's the bigger angle, right? EBF is right here, right? That's the blue. And then ABE is right there. That's the purple one. So those two do what? What do you do with those two? The EBF and the ABE. And add those together and set them equal to what? ABF. Yeah. And so it gets, there were other angles in there that we didn't even use. So that's where this gets a little bit more complicated when you get more stuff than you really need. So that's one of the tricks to the geometry portion that's on ACT is they give you more stuff than you ever need to do the problem. And they say, okay, I got all this stuff, and you really only looking at 2 or 3 pieces of it. So that's where the tricks come in. So solving this equation shouldn't be too daunting. So that's 13x minus 40, 6x plus 26. So it'd be 7x is equal to 6. All right, and then hold on. AB. Going to this direction. That's the right way, because what did I tell you earlier? Look at the smaller side. Left. I'm looking at left-handed. Sorry. All right. So ABF. So 6x plus 26 plus EBF 2x minus 9 equals 11x minus 31. Now that's going to work. 8x plus 17 would be 3x is equal to 48. And then x is, that works out much nicer, 16. And then they want to know, the only thing they want is measure of angle ABF. So I only have to plug into one of those, thank goodness. 6 times 16 plus 26. Measure of angle ABF is how much? 122 degrees. 10's using the same diagram, maybe I won't screw it up. If ray BD bisects angle CBE, ray BD, right there in that spot, it bisects angle CDE. So that's going to create these two angles being congruent to one another. And then ray BC is perpendicular to ray BA. So that puts a 90-degree mark there. The measure of angle CBD is 3x plus 25, and the measure of angle DBE is 7x minus 19. Find the measure of angle ABD. This one's a little bit more going on. So this is kind of like that number 12 that we did at the beginning of class from the segment addition things. You got to do one problem to be able to solve the problem they want. You got to do two things here. So what can we do? Okay, I can find x first. That'd be a good idea. How do I find x? Yeah, 3x plus 25 is equal to 7x minus 19. Now, why? Explain to us why those are equal. That's right. So why are those equal? That's right. So we got an angle bisector, so that creates the two congruent angles, which allows us to solve for x. Solving this, we get 4x is equal to 35 plus 9 be 44. So x is 11. And then it asked for the only thing it asked to find was the measure of angle ABD, which, so what do we do with that? Okay, plug it into C for CD and add 90 to it. Why are we adding 90? Yeah, it's a perpendicular lines or rays there, so that's 90 degrees is equal to the measure of angle ABD. So 33 plus 25 plus 90 is 148. There's our final answer. So good things to take away from this are on your diagrams, lightly make marks with your pencil that, especially when you have one diagram that's like for 4 or 5 problems, so that you can erase those and do the next problem with a clean slate out of that. That can really help you as you go along here. Most of this is not going to be that complicated, but there are some when you get to 9 and 10. There's only 10 problems on this. It's not anything too difficult. Short homework assignment.